So in this problem, we're told that 1 light year is the distance that light travels in 1 year. So how long or how far light can go in 1 year. And that is 9.5 times 10 to the 12 kilometers. And we want to figure out what the speed of light is in feet per second. So I would say first thing is we're not actually given a speed directly. We've got all the info we need, but we're kind of given a distance. So we have this 9.5 times 10 to the 12 kilometers. And if we want to make that a rate, a speed, we're going to divide that by the amount of time it takes to go that far, which is 1 year. So a light year is actually a distance, but it's easily converted into a rate. Okay, so if we want to convert this, our goal is feet per second. So I'm going to have to work on both the kilometers part and the years part. I think I'm going to start on the years part. So if we want to convert years to seconds, I'm going to work my way through a couple of fractions. I certainly haven't memorized how many seconds there are in a year. If you've memorized that, go ahead and use it. If you haven't, work your way up to it. I also want to point out that if you are ever doing this on a test and you hit a conversion that you just don't know, for example, like how many feet are in a mile, that doesn't come up in this one, but you can ask me questions like that. I'm not really so worried about you memorizing every unit fraction. I'm more worried about you knowing how to use them. So if you know what to ask me for, I will give it to you. So for this one, I'm going to go from years to days. So what I know is that there are 365 days in a year. I'm not going to worry about leap year. If you want to worry about it, that's fine. This is a tool for science classes, and I'll let them tell you exactly how picky they want to be about those things, but I want to see that you can do the math. So if we have 365 days equal to 1 year, this is one of our classic tricks for this class. You are always allowed to multiply by 1. That doesn't change the value or the size of what you're working with, it just changes its appearance. So we use that all over. We're using that when we change the appearance of fractions and radicals and so on. And we're going to use it here. If 1 year is equal to 365 days, then 365 days divided by 1 year is equal to 1, and 1 year divided by 365 days is equal to 1. So it's our big job here to decide which way do we want to build that fraction. And it's fairly easy to answer. If I'm trying to cancel years, they're currently on the bottom of my original fraction. They need to end up on the top of this unit dimensional analysis fraction. Okay, try not to write too big because I know I'm going to need a bunch of these. So right now, I started with kilometers per year, and I have kilometers per day. And I want seconds, so I'm not done. I know there are 24 hours in 1 day. And again, I get to decide when I build my fraction that actually just represents 1, who goes on the top and who goes on the bottom. So I'm going to put days on the top because I'm hoping to cancel days out of the bottom. And I'm going to put hours on the bottom. Oops, if I can write hours. HR. Okay, so now I'm kilometers per hour. And then if you need to go hours to minutes, minutes to seconds, this one I do have memorized, so I'm going to jump to the fact that I know that there are 3,600 seconds in an hour. So I'm going to say 1 hour divided by 3,600 seconds is equal to 1. And I'm finally down to kilometers per second. I'm still not entirely done because I didn't really want kilometers, I wanted feet. So personally, I don't have the conversions from feet to kilometers or meters memorized. I'm pretty good within one unit system, but I don't really have the ones going back and forth memorized. So it's fine. Again, you can ask me questions like that if I ever have you do something like this on a test. For doing your homework, if you need to go look a couple of them up, you can. I think I didn't get too crazy on your homework, but I went and looked it up, and I found out that, here, I'm going to erase some of what I wrote before so that you can see this one. There are 3.28 feet in 1 meter. I'm trying to cancel kilometers, not meters, so I certainly could have just gone and looked up kilometers to feet instead, but I wanted to show that it's very easy to get from kilometers to meters because the way our metric system works, kilometers are thousands of meters. So we can say that 1 kilometer is equal to 1,000 meters. And again, I've built the fraction with kilometers on the bottom so that I can cancel with the ones that were on the top in the beginning. And then last one, I'm going to say 3.28 feet is equal to 1 meter. So I tried to do a nice long one for you. And then meters cancel. So notice, I'm going to switch colors here, that I'm left with feet in the top and seconds in the bottom, which is perfect. So regrouping the calculation I need to do, we're multiplying fractions, so we go straight across, times 1,000 times 3.28, and then on the bottom I have 365 times, I hate that I'm writing times this way, scientific notation made me do it, 24 times 3,600, and this is going to be feet per second, and it is always okay to move those fractions in and out of the big fraction, or I'm sorry, move the units in and out of the big fraction. That's multiplication, so we can separate them off or we can put them back in, so I'm just choosing to separate off right now. And then this is a big messy calculation. You could do some rewriting if you want to, just reviewing our scientific notation. This is the same as 3.28 times 10 to the third, so you could do a little bit of that. Personally, at this point, I would just go plug it into my calculator, and I would say, because I did this in advance, 9.83 times 10 to the 23rd feet per second. So very, 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 very fast, which we hopefully aren't surprised by. If you were doing this in a science class, they would want you to think about significant figures. They haven't convinced us that we need to do too much of that in math class yet, so I'm going to stick with, I want to see at least a couple of decimal places so that I can see that your calculation was accurate. The exception to that rule would be if you're measuring something in a word problem that it doesn't make sense to have a decimal part of, then round to the nearest integer. So the number one thing is making sense with your answer. Otherwise, give me a couple of decimal places so I can see a little bit of accuracy. Okay, thanks for watching.